Hello. Yeah, today we'll be looking at the tree method for recurrence relations to solve its time complexity. So here's the question we want to look at. As you can see that this is the recursive part. This is the work done. This is the original problem. All right. So now what we're going to do is we will take t of n to give us 2t(n) over 2 plus n squared. Now, the next input is going to be t(n) over 2 is equals to 2t(n) over 4 plus n over 2 squared, right? Now, the next input will be tn over 4 is equals to 2tn over 8 plus n over 4 squared, right? Now, we want to look at a pattern of the input reduction. What's the input? The input is n, the first input. The next input is n over 2. Next input is n over 4. Next input n over 8. This reduction will continue until you get to the base case, up to the base case. Now, I will need to form a pattern of this input. Based on this input I'm saying, I'll take this as the index 0. This is index 1, index 2, index 3, and so on and so forth. This index, I would use I to represent it. So I'm going to say n divided by 2 to the power of I will give me the input reduction at any time. So when I is 0, I'm going to get n. When I is 1, I will get this first element here. When I is 2, I'm going to get this guy, all right? So at the base case, I'm going to equate this guy, 2 to the power of I, to 1. Because at the base case, the input is just 1, right? So n divided by 2 to the power of I is 1. That means n equals to 2 to the power of I. Take the log of both sides. So I'm going to say I is equals to log n base 2. Now, this is the height of the tree. Okay, so having gotten the height of the tree, I would look at the pattern of the sub-problems. Okay, look at the sub-problem. You start off with 2, right? These 2 here will produce 4, right? These 2 will produce 4. Okay, because 1, which is tn over 2, will produce another 2 tn over 4 plus n squared. Another one, because these are 2, right? So that means I'm going to call this twice. So another tn over 2 will produce 2 tn over 4 plus n over 2 squared. Okay, so you can see how the input will continue to increase. So it will start with 1 input. The next number of sub-problem is 2, which is this 2 here. This guy will now produce 4, which is 2 plus 2, that's 4. This is how this guy will now produce 8. And so on and so forth, until you get to the base case. This number of sub-problems now is like a pattern. So I can say 2 to the power of I, or use this to represent the pattern of each base case. I said base case. Each number of sub problem at each level. The reason why base case come to mind is because I want to use this to know the total number of base case. So the total base cases will now be 2 to the power of I at that base case level. And I is log n. That means at the base case, I'm going to get 2 to the power of log n. base 2. And 2 to the power of log n base 2 is n. All right. So this is like another a kind of, regular logarithm. So there's a rule in logarithm that you can use to, know what is going on here. So with that said, I've solved the base case because my T of n will be the sigma of the work done at every other level plus the work done at the base case. Now I know it as n times 1 because the work done for each of the case is going to be 1, right? So times all the total number of cases, that is, I'm going to have n times 1. So the work done at each of the level before the base case, we're going to start from I equals to 0 up to log n, which is log n minus 1 because I'm adding the base case. Now, what is the work done at each of the levels? The work done at this level is n squared. This one is this. This one is this. Based on this now, we can tell what the pattern will be, okay? The pattern will be n squared divided by 2 to the power of I, okay? Because if you take n squared, 2 to the power of I, at all times, you would produce the work done at each of the level, all right? So now, if you had the I value, if you use the I value here, when I is 0, this will produce n squared. And that's the first one here, okay? Now, if you take I to be 1, this is going to be n squared over 2, right? Cool. Now, this is what you get. But there's something I still need to let you know because this one is being produced by 1, right? So that means one of the sub-problem produced this. So 2 of them now will be 2 of this, right? So the total sub-problem at that level will be n squared over 4 plus n squared over 4, which is going to be n squared over 2, right? Now, so now I've gotten this second level, right? Total second level. The third level also will be n squared over, I believe what I have is 16, right? N squared over 16 plus n squared over 16, because it's going to be 4 number of cases, plus n squared over 16 plus n squared over 16. This is going to be 1 over 4 n squared. You see that? Now, this will continue. Okay, that's why I said n squared divided by 2 to the power of I will always give you the total work done at each level. Because when I happens to be 1, I'm going to get this. See that? Now, when I will be 2, that's when I will get this. You see that? Cool. So that's the idea. That's why I'm using this. This guy here will now be the key to solve the problem. So with that said, I'm going to say my T of n is n squared into log n minus 1, then 1 over 2 to the power of I plus n. I equals to 0. You see the reason why I brought out n squared, because n squared doesn't really affect, all what is going on here, right? So I just bring it out, treat it as if it's a constant, right? So this is 2 to the power of I. Now, so this is what I'm now using now. This guy here is what I'm using to solve this guy here. See that? So with that said, I'm going to look at the series. So sigma of 1 over 2 to the power of I, when I equals to 0, log n minus 1, what you have there is a series like this: 1 comma 1 over 2 comma 1 over 4, like that, right? So with that, I know that this is geometric series. So when I have geometric series, I'm going to look for the common ratio. The common ratio here is half. R now is half. That means R is less than 1, so I can use A divided by 1 minus R for it. So A is 1. Look at the series. A is 1. And the R is half. 1 minus half. Everything here will give me 2, right? So if I've solved this part to be 2, so I can say my T of n is 2n squared plus n. That means T of n is going to be big O of n squared. See that? So that's the solution. That's the solution for this problem. So it's going to be big O of n squared.